Hello, welcome to this lesson. In this lesson, I will cover the topics of how the distance relationship with the Earth relative to the Sun and its location within its revolution and the effects of the tilt of its axis affect the temperature within the locations in Earth, on Earth. Right, so I would like for you to understand these three basic concepts: the equator, the Tropic of Capricorn, and the Tropic of Cancer. You must understand that these locations are locations of longitude. The equator is at 0 degrees longitude. The Tropic of Capricorn is at 23.5 degrees south latitude. The Tropic of Cancer is at 23.5 degrees north latitude. I have an image representing this concept in visual form, of course, in this web page for you to view and understand more clearly. So now that you understand that these lines exist and where they exist and its longitude, and I can help you imagine how this ties into the concept of why the seasons exist and why the temperature of the Earth in certain locations differentiates during certain dates of the year. Imagine the Earth not at a 90-degree angle, of course perpendicular to the Sun, and to, maybe better said, to the ecliptic plane. The Sun would of course be hitting in the middle at the equator, and this of course will disperse the light of the Sun that will be hitting on the northern or southern hemisphere equally, of course, so it will be pretty much the same in this sense, temperatures of the Earth, if you compare it to north to the southern hemisphere. And so you can imagine this, and you can imagine if the Earth was to be tilted, then the Sun would not hit over the equator, it would hit either on the Tropic of Capricorn or the Tropic of Cancer on certain dates. But it is different, of course, it will not be hitting over the equator. And these things happen, although the Earth is at a tilt of 23.5 degrees perpendicular to the ecliptic plane on its axis, this does not mean that it is always going to hit away from the equator, because depending on its location within its revolution around the Sun, this can occur where the Earth is at a tilt, yet the Sun hits mostly over the equator. Okay, so what people have done is, to mark the seasons, they have taken the concept of the tropics and the equator, and on the dates where the Sun hits one of these more directly, to mark the beginnings of the so-called seasons, or different weather patterns depending on your location on the Earth. If you can take an example of the solstice that is going to come soon, which is the December solstice, which is the second solstice as well of the year. You can see that in a solstice, what constitutes a solstice is whether it is hitting not on the equator but either on the tropics, either Capricorn or Cancer. For the December solstice, it hits mostly over the Tropic of Capricorn, which is 23.5 degrees south latitude, which is located in the southern hemisphere. So in this state, of course, the southern hemisphere will receive more sunlight, and the people over there will be saying that it's summer solstice, and the people up north will be experiencing winter, and they will call it the winter solstice because they receive less sunlight. Because of this, in the northern hemisphere during the December solstice or the winter solstice, which is what we call that here, some of us, this causes us to experience shorter days and longer nights. The opposite is true for the southern hemisphere, experiences longer days and shorter nights since it receives more sunlight. This idea cannot be applied to the June solstice, or in the southern hemisphere it would be called the winter solstice because of its effects over there in that location. The equinoxes, there are two of them, because on 2 dates of the year, two locations within the Earth's revolution around the sun hits the Earth more directly onto the equator. This, of course, like I explained previously, equates to the southern hemisphere in this sense experiencing more similar weather and more similar amount of sun hitting over them. This, of course, equates to equal length of days and nights. There are two of them, two equinoxes, two solstices. Also, you should understand that the solstices do not occur within a certain date. Within the same date, every year it can vary. I mean, like the December solstice, it can occur during the 20th, the 21st, the 22nd, or the 23rd, and of course, this idea can be applied to the other equinoxes and the other solstices. They differentiate in which day of the month they occur, depending on the year. This is an imperfection of our calendar. Just one example. Okay. I would like to share to you the distance relationships of the moon and the earth and how we can label them. When the moon is farthest away from the earth, this is named a moon apogee. It is at a distance of 406,700 kilometers. When it is closest to the earth, it is the moon perigee. It is 356,400 kilometers from the earth. So that's more simple than what I have stated before. I have two images, of course, to help you along to visualize what I am saying, but I would like for you to create your own visualization. I would like for you to draw the earth on the tilt of its axis, and since this is based upon it on the ecliptic plane, I would like for you to draw the ecliptic plane as well. I would like for you to label the degrees that it is perpendicular to the ecliptic plane. I would like for you to draw the sun, and I would also like for you to label the Tropic of Capricorn, the equator, and the Tropic of Cancer, which hemisphere it is located in, and what their longitude degrees are. Alright, so this is that is it.